Alright, we're on section 12.4, and the plan for this section then, there's three types of problems I want to cover. The first one talking about triangles and parallelograms, more so triangles, but we'll talk about the connection to parallelograms. The second type of problem then is going to be torque, and the third type of problem is going to be the triple box product, or also known as like the volume of a parallelepiped. And so we'll get to that one when we get there. So let's talk about this first type of problem then, where we want to find areas of triangles and parallelograms. And so the first problem then is I want to find the area of the triangle with these points, all right, P, Q, and R. And so what does this look like? Well, essentially what we want to do then is in three-dimensional space, right? So this is how we draw three-dimensional space. Here's X, here's Y, here's Z. So 0, 3, 4 means I go, and this is, so these are the positive axes that are drawn. So 0, 3, 4 is 0, and then I go to 3 over on the y-axis, and I go 4 up, so it'll be like here, right? So this is going to be 0, 3, 4, okay? And then 2, 4, 5, I'm going to go 2 down here, and then I'm going to go 4 up, which is going to be like here, and then I'm going to go 5 up, it's going to be like here-ish. Alright, so this is going to be 2, 4, 5. So this is point P, and this is point Q. Point R is going to be negative 4, 6, 5. So that's going to be 4 back. So it'll be like back here. 6 over, 5 up. Alright, so this is going to be Q. Alright, negative 4, 6, 5. And so there's going to be a triangle here that's going to look something like this. Alright, and I want to find the area of this triangle. And so how do I do this? Well, the idea is that the area of a triangle is equal to 1/2 the magnitude of a cross product U cross V. So what we're going to have to do then is I'm going to have to form two vectors from these 3 points, right? And so I guess this is R. PQQ, that doesn't make too much sense. So this is PQR, okay. Alright, so those are my 3 points drawn above. And so I just need to pick any point. Let's say I pick P, alright, and then I have 2 vectors, alright. I form this vector, and I form this vector, and then we'll call this U and V, right? So let's then call this one U and this one V, and then I just have to cross them. So step 1 then is to find the vectors from these points. All right, sometimes you might just be given these vectors. So what is the vector PQ? Well, it's equal to 2 minus 0, which is 2, all right, 4 minus 3, which is 1, and 5 minus 4, which is 1, okay? And so that's the vector PQ, and we'll call this U. All right, then I want the vector PR, which is going to be equal to negative 4 minus 0, okay, stay. Right, negative 4 minus 0, which is negative 4. Okay. 6 minus 3, which is 3, and then 5 minus 4, which is 1. So 6 minus 3 is 3, 5 minus 4 is 1. And we'll call this V, right? And so what's the cross product of U and V? Well, U cross V is equal to IJK, right? 2, 1, 1, negative 4, 3, 1, okay? Which is equal to, then, it's equal to I times, so what you do is you like cross out the row and column that contains I, and then you take this block down here. So now I have I times the determinant, this is called the determinant of 1, 1, 3, 1, and then we'll show you how to figure that one out. And then, so that's that part. And then the next part is minus J, all right? And you always have a minus J here, times the determinant. Now this is 2, 1, negative 4, 1. All right, you guys see that? And then finally, we're back to a plus K. And then if we knock out K, this becomes 2, 1, negative 4, 3, okay? And so this is I, and so what you do is then you do these guys minus these guys, or that's the wrong color. So the diagonal minus these guys going up. So you multiply them. So this is equal to 1 minus 3, okay? And then this is minus j times 2 minus a negative 4. All right, you see how that works? So 2 times 1 is 2, and then you minus a negative 4, okay? And then plus k times 2 times 3 is 6 minus a negative 4. Right? And so that's how you calculate these 2 by 2 matrices here. It's called taking the determinant. So you just take this guy, the diagonal, minus the guy going up, okay? And so now you get negative 2i minus 6j plus 10k, which essentially is the same thing as the following, is negative 2, negative 6, 10. All right, and there are many other ways you can calculate this cross product. So this is actually a determinant. This is a 3 by 3 determinant. So this is a 3 by 3 matrix, and you're actually taking the determinant, and this is a 2 by 2 determinant. And so if you on Google, you can find many ways to solve 3 by 3 determinants. This is just one of the ways, breaking it down to smaller 2 by 2 determinants and solving. And in Math 240, you're going to get really comfortable with solving determinants if you go on and take that class at all. All right, so this is going to be U cross V. All right, the cross product returns a vector. And now I need to find the magnitude of U cross V, which is going to be the square root of 2 squared negative 2 squared plus negative 6 squared plus 10 squared, right? Which is, this is 4 plus 36 plus 100, which is the square root of 140. Okay, and then the formula for triangle is 1/2 of this. So, so the area then is going to be 1/2 of root 140, and I guess you can take out the 4. What do you even get? You get 35. So you get 2 root 35 over 2. And so the area of the triangle is root 35, okay? And so how does this tie into parallelograms? Well, when you have these two vectors, 2, 1, 1 and negative 4, 3, 1, right? So that's PQ and PR, right? PQ and PR are 2, 1, 1, right? And negative 4, 3, 1. So that's U and V. When you cross them and you take the magnitude, you're actually finding the area of this guy, the entire thing, all right, of the parallelogram spanned by U and V. And so we need to take 1/2 because we only want the area of this triangle right here, okay? So be careful on your exams when they ask for the area of a parallelogram. Make sure that you don't divide by 2, right? You find some cross product. So area of a triangle is that, and then area of a parallelogram is going to be just the magnitude of U cross V. And hopefully this picture above shows you why that's the case. And yeah, be careful on if the question is asking for triangles or parallelograms. And this is then the first part of chapter 12.4.